Hey everybody, it's Mr. Woodward. In this video I want to introduce this lab called Collision Carts, which is an introduction to momentum and the way that momentum is conserved in different types of collisions and explosions. So first of all, I wanted to show you in the top right corner, I've got these equations. The first one says P equals m times v. So P is the letter that we use in physics for momentum. One reason is because the letter m is already taken, right? M already represents mass, so we need a new letter P for this quantity called momentum, okay? And so momentum is just the product of mass times velocity, okay? So m is for mass, v is velocity. When you multiply those together, you end up getting units of kilograms times meters per second. And those are the strange units of momentum. Okay, so when we talk about momentum, we're talking about units of kilogram meters per second. Okay, and then in addition, I've got this other equation, which is just a way of talking about the change in momentum, right? Delta P, change in momentum. Anytime we're talking about change in physics, we're always doing the final minus the initial. So in this case, I'm just showing the momentum after a collision minus the momentum before a collision. Okay, change in momentum. All right, so that's the introduction to the general equations for calculating momentum and change in momentum. And so in this simulation, you're going to see 6 examples of collisions or explosions, and I'm just going to show you kind of how it works. So in the first example, you have what's called an elastic collision where one of the objects is at rest. So here you have a red car moving to the right at 2 meters per second, and it collides with a stationary blue car. Okay, but in front of the cars, there are these springs, and so they're going to bounce off of each other. Okay, so when you see elastic, you can think of bouncing. In the second example, you have another elastic collision, okay, where we've got these springs again, but now both of the cars are moving to the left. So you can see the velocities here. This car is moving at negative 2 meters per second. This car is moving at negative 8 meters per second. So the red car moves to the left, and the blue car moves to the left with an even greater velocity. So it's going to catch up to the red car, and then they should bounce off of each other again because we still have those springs controlling the elastic collision. Okay, so we start off with 2 elastic collisions, and then we get into some inelastic collisions. Okay, so inelastic means sticking. They're going to stick to each other. And how are they going to do that? Well, now in front of the cars, they have these, which are a couple of magnets. Okay, they're not springs anymore, they're magnets. So they're going to stick to each other. Okay, so this time we've got the blue car moving with positive 9 meters per second, so it's moving to the right, while the blue car is moving to the left at negative 4 meters per second. Okay, they're going to collide with each other, then they're going to stick, and then when they stick, they will either both come to a dead stop, or they will move together to the left or to the right. In number 4, you've got another inelastic collision. Again, they've both got those magnets on the front of them, but now the red car is starting from rest, and the blue car is going to move to the left and collide with it. They'll both stick together, and then they'll move together. All right, and then finally, you're going to see some explosions. So now we've got in between the 2 cars this bomb, and when the bomb explodes, it's going to send the cars in opposite directions. So the blue car is going to go this way, the red car is going to go that way. And then similarly, for the last one, another explosion, but now it's an explosion while they're moving. So there's the bomb in between them. But before the explosion, both cars are moving to the left. And then after they explode, you'll see their velocities change. Okay, so that was elastic collisions, which means bouncing, inelastic collisions, which means sticking, and then an explosion, which means that they're moving apart from each other. So let's do the first one together just so you can see exactly what I'm looking for. And I'll show you how this works in the simulation. Okay, so we're starting off with an elastic collision where one of the cars is at rest and the other car is moving towards it. So the red car is going to be moving to the right at 2 meters per second. It's going to have an initial mass of 1 kilogram. The blue car's initial mass is 1 kilogram. And then I'm going to try to draw what happens here after they collide, and then I'm going to label the velocities of both cars, okay? So I'm going to import this information into the simulation that you will have access to. So the simulation is here, okay? And I'm being asked to, first of all, set the mass of the red car to 1 kilogram. So you can see that I can control the mass down here on the bottom. I'm going to set it to 1 kilogram. The mass of the blue car needs to be 1 kilogram. So that would be this one. And then I can even move them like around towards each other. I want to make sure that they're going to bounce off of each other. So on the bottom, I can choose between these different types of collisions. So I'm selecting these green boxes on the very bottom. And I want the elastic collision, which is where they have the springs in the front. Okay? And then finally, I'm going to set their initial velocity. So the red car is supposed to have an initial velocity of 2 meters per second. So I'm going to increase the velocity using these arrows, right? I'm going to set that at 2 meters per second, and the initial velocity of the blue car is at 0, so that's already set. Okay, I'm going to hit start. They're going to move towards each other, and then I'm going to pause it right after the collision, okay? So after we can see that the red car came to rest and the blue car moved to the right at 2 meters per second. So that's what I'm going to draw here. So the red car after comes to rest, its velocity is 0, and the blue car moves at 2 meters per second. And I mean, might as well color code it, right, to make it just a little bit more obvious. So there's our red car, here's our blue car. Okay. And now I'm going to fill in the table. Well, here first, I'm going to ask you to try to explain why the cars did what they did. Like, why did the red car come to rest? Why did the blue car move to the right? But then after that, we're going to fill out the table to show the momenta, which is the plural of momentum for both cars, okay? So it says use P equals M times V, right? Momentum is mass times velocity. So here we go. Starting with the red car's momentum before the collision. Okay, so before the collision, the red car had a had a velocity of 2 meters per second and a mass of 1 kilogram. So this is just going to be 2 meters per second times 1 kilogram, which is a total momentum of 2 kilogram meters per second. And I apologize, I kind of wrote that backwards. It should have been the other way. Do mass times velocity. 1 kilogram times 2 meters per second is 2 kilogram meters per second. Okay. What about the momentum of the blue car before they collide? Well, for the blue car, its information is up here, right? Mass of 1 kilogram moving at 0 meters per second. So 1 kilogram at 0 meters per second means it's got no momentum. And so the total between them is just 2 plus 0, which is 2. Okay, what about after the collision? So now we're looking at this situation. Okay, for the red car's momentum after the collision, well, it's got no velocity, so it's going to have its mass of 1 kilogram times 0 meters per second is a total momentum of 1. And then I will include the units. And then the blue car here has a mass of 1 kilogram, but moving at 2 meters per second. So now I've got and my bad, folks. Math error here, right? 1 times 0 is 0. And so if I add them up, I get a total of 2. Okay. Those are my totals, and now I'm ready for my change in momentum. Okay, change in momentum. So remember, change in momentum is the final momentum, or the momentum after, minus the momentum before the collision. Okay, so I'm just going to say for the change in momentum, well, the momentum after here was 0. The momentum before was 2. So this first one is 0 minus 2, which equals negative 2. That means the red car lost 2 units of momentum. Okay? And then for the change in momentum of the blue car, well, the blue car's change in momentum is its final momentum of 2 minus its starting momentum of 0. So now I've got 2 minus 0, which is positive 2. And so the total of both of those, filling out this box down here, right, is just going to be negative 2 plus 2, which equals 0. That was the total change in momentum of both cars because the red car lost 2 units of momentum, but the blue car gained 2 units of momentum. So the total change between the two of them was 0. All right, so that's in general how to work through these, and then you will have 5 more examples to plug into the simulation to describe and then draw and calculate.